Let's address the requirements engineering aspect. And the first thing I would like to stress is how sometimes engineers are uncomfortable with requirement engineering. Why? Because engineers love to write solutions. And when you write a solution, you have a very concrete way to verify whether your solution solves your problem. But when you do requirement engineering, what you need to do is to write or to describe the problem. And when you describe a problem, it's a bit more difficult to verify whether your description is correct or what is the quality of your description. That's why there are some approaches that try to avoid these requirements engineering, or at least try to make it as close as the design of the solution, as close as possible to the design of the solution. But I will talk about that. The first thing I would like to refer is about this idea. When you do requirements engineering, what you do is to describe the problem space and distinguish this from the solution space. So in the solution space, basically you build an artifact, or you are describing the solution. Even if you don't build an artifact, for instance, if you design the architecture of your system, you're not building the concrete artifact, but the models or the descriptions you are writing describe the solution. But when you do requirements engineering, actually what you do, you are describing the problem. And in more pure approaches to requirements engineering, I would say that you don't care about what is the structure of the solution, you are just describing the problem. But this relation problem solution is a bit is not that straightforward, in the sense that actually when you have a problem, usually this problem becomes the solution of the next phase. So imagine, okay, you design, you describe your system, the requirements for your system, okay, and that becomes, so this in the problem space. And then you look at these requirements and you just look at these as a problem, and the problem is going to be, okay, let's write or design a system to solve these requirements, and that's the solution. But then the requirements, the software architecture of the system becomes a problem, is how I'm going to implement this software architecture. But actually, even the first description of the system, of the requirements of the system, are already a solution, because you actually have an initial problem, which is, well, I have something that I have a difficulty or an opportunity that I want to address. And what you do, and this is a problem, and the solution, you just define a business case, and that's the solution. But then business case is local. Okay, if in the business case you look, well, there's an opportunity here, and then you can look at the business case now as a problem, that which system is going to solve my business case, okay, and then describing specifying your system can be seen as well as the solution space of the business case. So just to have this idea that actually you have problem solution, and so the development of a software product goes through several phases, where a software artifact goes through several phases where you sometimes look at the same descriptions either as a solution of something or the source of the problem that you want to solve with the next solution. One of these aspects, for instance, is that you can distinguish user requirements from system requirements, in the sense that the user requirements is the solution from the user perspective. So the user looks at the business case and says, well, if I have a system that does A, B, and C, this will solve my problem. But that becomes actually the problem of something that you need to define. Is you need to have a more clear description of the system, and then you have the system requirements. So one is the user requirements that describe from the why I'm going to the way it's going to be used, or the way these to be artifact, software artifact will solve the business case. But then you need to have a more precise description of the system where you really are not focused from the perspective of the business case, but you are focused for the perspective of how are you going to implement this business case, and you have a system requirements. Most of the time, we as software engineers, we design or we specify business requirements after talking with users and identify the user requirements as well. But then the main goal, okay, let's in a more traditional approach to requirements engineer, the main goal is to design and to describe the requirements of the system you're going to implement. So before the software architects start describing what is the architecture of that fulfills these requirements. So what you need to describe when you are going to describe your system, okay, do the system requirements, both the behavior and the constraints. Usually the behavior you describe as functional requirements and the constraints as non-functional requirements. So functional requirements, you may look at the system has to do that. And non-functional requirements is the constraints on how to do it, for instance, in terms of performance or security. Okay, it as usual is nice to have these classifications so that you have more clear ideas when you look at things. You can look from this perspective, because that's what actually classifications give you, is a perspective to look at things. But of course, should be always careful that sometimes the borders between them are not is a bit blurred. Okay. And the sense that, for instance, if you have to create an account, is a functional, okay, requirement. Transaction should be executed in less than 1 second is a non-functional requirement in terms of performance. Process an adventure, okay, let's say that is a functional requirement. The system is available 5 minutes per day maximum. This is a non-functional requirement in terms of availability, but when you write only authorized users can use the system, maybe, okay, you say, well, it's a security, actually, so it's a non-functional requirement. But then when you need to implement this non-functional requirement, you identify functionalities you need to implement. For instance, well, it's the login. So that's where things start to mix. But anyway, it's important to distinguish from functional from non-functional requirements, although sometimes some of the functional requirements result of the need for non-functional requirements. Another thing that is particularly important is what are the qualities of requirements. You will find a lot of different lists. I think that probably these 3 qualities synthesize what is more important when you look at requirements. We'll find probably a lot of different variations of this, but first is that requirements should be complete, in the sense that your description of your system should address everything, of course, because if at the end you are going to implement it, you need to know everything about it. Should be consistent, in the sense the system could be actually implemented, so there is no 2 requirements, for instance, that are contradictory, okay, so that they cannot be implemented together. And what is really important, they should be measurable, in the sense that at the end you should be able to, when you have the system, to verify whether it fulfills or not the requirement. Another aspect that is important when you do requirements engineering is okay, the software requirements document. Basically, how are you going to describe it? And there is here a spectrum between natural language and formal descriptions of the requirements. And actually, you're going to play in this spectrum. You'd be really happy that you could formalize all the requirements. So use a formal language to describe your requirements. Unfortunately, this is not possible for most of the problems because we already described that when I talk about the EP systems, okay? And not all the systems are S systems, okay? But so you need to use a natural language, but there are some variations. For instance, you can have a structured natural language. What is structured natural language? You put some rules on the way you use the natural language, so to reduce ambiguity. Because the problem of describing a problem or describing your system using natural language is it's very easy that there are misunderstandings about what the system is. So we'll find all these different approaches, and depending on the type of the problem you address, we'll go for we can survive, let's say it, with the natural language only. It's difficult to avoid natural language, okay? And if you have a more critical system where the loss, okay, is high, okay, if there are problems, then you start using more formal approaches that the main advantage is that they allow you to automatically verify some of the qualities of the system when you are addressing the requirements, when you are describing it. So in some sense, they help you to validate your requirements. So if you have more formal approaches, unfortunately not everything can be, or most of the systems cannot be completely formalized. And of course, when you are doing requirements, you have a requirements engineering process. So I've been talking about basically the artifacts or for instance, using natural language to describe your system, but there's a process to do it. And basically, the process has two main activities or two main goals. One is elicitation, requirements elicitation, and another is requirements analysis. So in requirements elicitation, you address all the techniques that allows you or helps you to gather the requirements. So for instance, how to talk to people, interviews, you can then ethnographic studies where you observe people working so that you can, for instance, you observe. So for some systems where, for instance, you have very specialized people, so how doctors work. It's important to observe because they have very specific domain knowledge. So you probably is not enough to interview them or to have surveys, okay? Or another technique to do elicitation is to read documentation. So there are several techniques to do elicitation of requirements. And after you gather all this information, you need to analyze it. So you need this feeds you in order to actually design your system, because it's just not the result of the observation of gathering that your requirements, your system requirements is not just the result of gathering the requirements. You need to analyze them, you need to cross-check requirements, you need to start to write more precise specifications of the system, and that's what is called requirements analysis. And then you have requirements validation. As you see, in the problem space, you are doing almost everything that you do in software development solution space. So you identify the requirements, you verify the requirements, you analyze the requirements, you validate the requirements. Well, so that's why some people say we should have these two things together. But when it comes to requirements validation, you need to worry about several aspects. One is what you want to validate. For instance, are they real requirements? Okay, do they make sense? Okay, are the requirements, so I can validate some of the qualities. For instance, are they, it's do they have concrete measures in the sense I'll be able to verify that my system conforms or fulfills this requirement. Okay, are they complete? Is something missing? So there are the kind of things that you do to do the requirement validation. And the techniques you are going to use to do the requirement validation is going to be like reviews of the requirements. So people read the requirements, different people, and we'll see different techniques of reading the requirements. So you have to learn about reviews. Another is prototyping. So you, from the requirements, you write a prototype. So that's one of the approaches that puts requirements engineering closer to the system design, okay, to the solution space. Okay, and another one is you look at the requirements, you try to write the test cases. So it's another way to validate requirements. If you are not able to write test cases, okay, for your requirements, means that probably they are vague or difficult to understand. And finally, we have requirements management. So when you do requirements management, basically is we have if you have thousands of requirements, you need to do planning. Okay, so we have a large number of requirements like identification. Each requirement has a unique identifier. How to deal with traceability in the sense when you look at a requirement, who was responsible for this requirement, or if this requirement had different versions because it's changed. So keep all these descriptions. So the same way you have your code base, you have different versions of the code, at the end you finish with having several versions of a requirement along the time as you refine them, as you identify or more requirements, of course. So that's why they need tool support. And then you have associated with requirement change management, that you have a system, and then you basically you just change a requirement and you try to identify what is the impact of it on your system and in the other requirements. Just a final word on agile requirements that are on the other side of the spectrum. So where actual requirements are closer to, 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 to the software development. So in agile requirements, actually your requirements are stories. And the stories have a value, of a dimension. So there's not a big big emphasis on the complete description of the requirement. So I would say that when you do agile requirements, the requirements documents by themselves are not enough. So some approaches for requirements engineering try to have the requirements document contain everything. So you, after you have the requirements document, you almost can ignore your clients. You just look at the requirements document and you can implement your system. Of course, this puts a lot of pressure on designing, on writing all these requirements, which is tough. Why? Because as you see, it's much more difficult to verify something that is in the problem space. So it's vague and it's in the problem. Okay, so here they do not put that much because actually they have the during development someone from the problem space, a client is in the team. So actually the requirements are there in the considering that person. Another thing that helps these to reduce this pressure on having a huge and complete requirements document is to have small, short releases. Of course, because then you only need to identify a little bit of requirements, you release, and then you identify more. Because when you are working in the problem space, if you keep having thousands and thousands of requirements, this can become very, very difficult to manage. Okay. So, and of course, requirements can be changed, which look cannot change if you have this document that basically isolate the team from the client. This huge document. Okay. You have this difference between the product log and the Spring log backlog. the product backlog and the sprint backlog, where you actually deal with what can be changed and what cannot be changed. So they try to reduce this emphasis on requirements, and in some sense they reduce the cost of having this complete requirement specification that isolates the client from the team. Okay, that's all.